Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video is pretty fun. I've taken a problem that I've done for one of the advent of codes, the Matthew Scroggs.code.uk puzzle advent calendar, and I over-engineered the heck out of it just to try to learn something. And so here was the problem from day 4. And it was basically, and you can look up this video if you want to. There it is. Only 36 people have looked at it so far, but I just think this is a very interesting problem when it comes to like taking something like this and just over-engineering. So basically, it's just a series of equations that you're trying to figure out what values from 1 to 9 work. So I set up permutations, and I just said, if this equation works, and if this, and, there's 6 different ones, then just print out. In this case, it was just printing out the 3 values together. And then you call it a day, and the answer was 160 when it comes to multiplying the 3-digit numbers that came together. And so I just had this random question in my head. I was just like, and I figured there probably was an answer for it, and it probably, since it was Python, there was probably really a fun, simple way to do it. And I was like, well, how could I make this more generic? And then at the end, by the time I was done with it, I was like, you'll see in a second here, it was like, there's no way. Like, this is pretty understandable. You're like, okay, I have a series of equations. I run some permutations through this. Well, let's just see what happens here. Take a look at this code. What do you think? Boom, there you go. How hard could that be to read, right? That's so simple. And it gets me to the same place. But the question was, yeah, so it might take a little longer because it's doing quite a bit more under the hood here. Here's the series of values that I need to solve that series of equations, and there's the 160. In that video, I should have just printed out the value. I mean, there was nothing stopping us from doing that. It's just that I neglected to do so. So what is this program doing? Huh? This is taking something like that was so hard-coded and moving it to the complete opposite end, where everything is now a lot more generic and so it might be hard to read. Like this code, if you don't like, it's one of those things. Once I have this working, this would be put into the just forget about this code and worry about the numbers up here. Because what this is saying here, like I say, I'll get to here in a second just to describe, but this is saying these are the elements. There's 6 problems, and there were 6 separate equations that needed to be solved. So these are the elements in which I need. Can I go back to that? Yeah, you're saying, so I needed the values that indexes 0, 1, and 2, 3, 4, 5, 6, 7, 8, 0, 3, 6, so forth and so on. And you can see that that's what these values are here. And then each one of those problems has 2 math operations. So I made in this case, this is a list of lists, and this is another list of lists with strings for the operations: plus, minus, multiply, divide, minus. You can read, so I'm not gonna trouble you there. And then what are the final solutions to the problem supposed to be? 5, 5, 10, negative 6, 18, 35. And so now this is where things got interesting for me, because this is a dictionary. I always want to say map, but it's a dictionary in Python. And I'm applying this string to the operator for an addition, and this string for this operation for subtraction. This is for multiplication, and this is for division. And so there's 2 divisions in computer science. There's the floating point math, and then there's the integer math, integer division and floating point division. And in this case, I was using true div, which is the straight up, just one div, one divide by sign, versus the integer division, which is the double integer, or the double divide by sign. Because the whole point of this was to get everything, if it works right, then everything will work out to the integer level and not to the floating point level. So what this is doing, and so for value and permutations range 1 to 10, so this is I can't, I'm not, well, I can go back again. Is that the same code as here? Yep, that is the same code. For all the same permutations of the values 1 through 9 in a list, unique values 1 through 9 in a list, go ahead and say, well, how many correct answers do I have? And in this case, I go through all 6 of them because of this here, and then I say, oh, if there were 6 correct answers, print everything out, and you can see I only print out the one value just like before. But what this is saying here, and this is again, you can see this, like operations, like how many different subscriptings am I doing to get this job done? But ultimately under the hood, what this is saying is say, get me the data from this, the 0th element, add it to the element at the first element, and then take that result, and then take that and use that as the left-hand side, subtract, and then take the second element, and then get the value, and if it's equal to 5, then add 1 to correct, and do that for every element in here. Go for these 3 elements, do a plus and minus, do these 3 and go plus and multiply, do these and divide, equal, just like you saw in those problems. And so, and it makes sense that there's 3 elements and 2 math operations. So this goes in between, this goes in between the first and the second elements, and this goes between the result and the second element for each of these. And then at the end of the day, you just compare to this guy. And then the cool part here is this, since this string maps, you can call that operator as a function using the parameters, 2 parameters of the thing that you're going to be supplying for the operation you're supposed to be performing. So in this case, say get me element 0 and then add it to element 1, or divide by multiply. That's what the operation does. And so again, this thing is absolutely crazy, but this is so generic now, because now if I really wanted to play with this, I can tinker with I can add more if I wanted to, all of this kind of stuff. Change this real, I mean, not that you couldn't change it real easy before, but now if I wanted a 7th equation, I just add a little bit of work over here instead of having to add an if statement or just change things around. And the whole point of this is it's over-engineered to all holy heck, but it gets the job done just the same. And which version is better, right? Well, this taught me a lot. I'm starting to really Python with the iter tools, with caching and permutations and this and that and everything else, and now with operators and like I said, like I use maps a lot in C++, and so dictionaries make sense too. It's just learning the syntax, because Python still is kind of, for me, a halfway new language. I've only been working with it basically in the advent calendars here, and I really enjoy the setup here of Visual Studio Code. If you know a better way to set up Python and use it, I'd love to hear about it. But right now, Visual Studio Code is awesome. I don't have to think about things, and it has IntelliSense. That's the thing that for Python, for me, that was always driving me crazy. It was like the IntelliSense of this was non-existence with the other editors. Here's my Thani that I was using before, and then like, why would we use that anymore? We have Visual Studio Code. As cool as Thani was at the time, and I get to debug. Like, that was the thing that moved me over to Thani from just the Python idle editor that I was forced to use when I was teaching stuff a couple of years ago, because that was the only thing on our system, is that it didn't have any of those, not even a debugger, at least that I was aware of, that was easy to use. So now, but this does everything, and maybe there's a better tool, but right now I'm happy in my land here. So if you have any questions, or if you have a better way, if you have a way to even over-engineer this more, or to change everything, this is the fun part of experimentation. This is research. This is experimentation, trying to learn for yourself, but also trying to figure out, is there a better way to solve problems? That's what research is. So if you know something, or if you have any questions, or you just want to say hi, comment below. And it's getting late for me. I'm going to bed. Thanks for sticking it out as always. Have a great day, everybody. I'm going to see you next time.